It's an absolute honor to be here and to tell you a little bit about the Air Shepherd initiative and the Air Shepherd program. Just a little bit about UDS. We've been entrusted with running the Air Shepherd program, which essentially allows us to fly drones beyond visual line of sight in a lot of the national game parks in South Africa. We also have a commercial side to the business, to the operation, and where we fly BVLOS operations for security and surveillance to mainly protect rail infrastructure, container depots, and other national key points, including mining assets back in South Africa. And a lot of the money that we earn out of that operation goes in part to fund the Air Shepherd initiative. Some of the core technical competencies that we applied to the Air Shepherd initiative were design and fabrication, systems integration, some composite engineering, embedded microprocessor development, a lot of mobile application development, and we do a lot of flight and training on small UAS systems. I'm going to speak a little bit about beyond visual line of sight because this is generally a hot potato, I think, in the US, and certainly in South Africa, civil aviation have taken a different approach to beyond visual line of sight. And the only reason we got this dispensation was because of the rhino and the wildlife crime issue. So some of the minimum requirements that are really needed to perform safe beyond visual line of sight operations, and I'm going to these are just a couple of them, but telemetry for aircraft is a very important factor. It's important that we have a very robust primary command and control link, and that we have a backup secondary link for redundancy should there be a failure. The endurance on the UAV needs to be such that it is capable of completing the mission at hand with a safe reserve. The reliability of the UAS is also critical in terms of having recorded a number of flight hours to establish the mean time between failure of certain key critical components so that we can establish a proper preventative maintenance schedule to ensure safe flight operation. The ground control station software must be comprehensive enough to allow us to detail mission planning, including terrain avoidance where applicable. We need a decent heads-up display for the pilot interface because this is the way that he operates this aircraft. A map with real-time positional data of the aircraft relative to the ground. Warning indicators that are that have configurable thresholds to monitor the system. And also the ability to set fail-safe elements to allow, in the event of anything going wrong, that the aircraft does what is expected of it. The other important elements to beyond visual line of sight flying a Mode S transponder, and in certain cases where the safety case dictates that a ballistic parachute is required, if we have to fly near highly densely populated areas, that's another one. And last but not least is compliance with the regulatory authorities in those respective areas. Now, we had to comply with civil aviation back in South Africa some 4 years ago. They passed legislation which allowed us to obtain our ROC, which is an operator certificate. And fortunately, we were the only company in South Africa to be awarded BVLOS accreditation because of the way in which we approached the safety cases that we built around our BVLOS accreditation. All of our pilots are licensed. We have something like 75 pilots in the loop now, and we have something called an RPL license, which is essentially it's not the same as your Part 107 UAS license in the US. We have to do all of the PPL required subjects that a normal PPL licensed pilot, a manned aviator goes through, including the radio operators course. We also have to be checked out by a DFE, and we have to perform flight maneuvers for each of the different platforms and obtain a rating on each of these platforms. We have to have controlled airspace certification. And before we allow a pilot to become PIC for a BVLOS operation, he has to have done at least 200 hours as an assistant pilot for a BVLOS operation. We also have been exposed to BARS, and for those that are, it's a BARS referenced audit that we endure every single year to ensure that our safety standards are of the same level as the manned environment. So for those of you not familiar with what a heads-up display would look like for a remote pilot, this is a very simple heads-up display. To the top left-hand corner, you've got standard artificial horizon with ground speed, airspeed, GPS health, heading, compass bearing. Below that is a user configurable area that would allow us to configure different information that we may or may not require. Could be RSSI values of a data link, and so forth. To the right-hand side is a map with the position of the aircraft relative to the ground and some other pertinent information, and this is what the pilot uses when he flies. The other thing that changed civil aviation in South Africa's attitude to the way in which we conducted ourselves was that little piece of equipment called a Ping 20SI Mode-S ADS-B transponder. Very small form factor, very light, 20 grams in weight, programmable via a mobile app, and this gave civil aviation huge comfort to know that they could see us. 90% of our operations are conducted at night. I'm going to speed this up a little bit because I've got a short video to show you. There's a fair amount of off-site work that goes into planning a night operation. Some of the additional requirements are navigation lights that must comply to manned standards. The Mode-S transponder, a 3-man team consisting of a pilot in command, sensor operator, and radio operator. And I'd like to show you the short video to give you an insight into what actually goes on while this operation is being performed. This is actually in controlled airspace near Cape Town International Airport.
Yes, we are at drone at Epping Industrial, requesting permission to operate from Bontiava to Nyanga train station, 400 feet and below, and will remain west of the extended center line 19 at all times. Okay, hold on for me. Okay, I'm going to give you a score, and then you must just call me on frequency. Okay. Tango, Oscar, Foxtrot. Alpha. Right, the score for the evening is 3775. 3775. Yeah. Cool.
Take off to 250 feet.
So that's the pilot in command, just explaining what the flight path is going to be for the evening.
Captain Tower, good evening. Zulu Tango Oscar Foxtrot.
Tango Oscar Foxtrot, I'll be back with you shortly.
Stand by.
Okay, 174, request taxi for links. 174, taxi Alpha, cross runway 16, holding point runway 19. Next 618, runway 19, clear to land, service wind 180 degrees, 12 knots. Clear to land 19, 618. 31372 behind the Embraer, turning from approach 3 miles, line of point runway 19 behind.
Galaxy traffic turning from approach runway 19 to line up and wait 19 and full length behind, Springbok 372.
Tango Oscar Foxtrot, go ahead.
Tango Oscar Foxtrot at Epping, requesting permission to launch and operate from Bontiava to Nyanga train station, 400 feet and below, and will remain west of extended center line 19 at all times. Tango Oscar Foxtrot.
Tango Oscar Foxtrot, QNH 1025, reports complete. Maintain listening watch.
1025, report complete and maintain listening watch. Tango Oscar Foxtrot.
The team would now go for the launch. That's a launch at night in an industrial area. You can see the navigation lights on the aircraft. That's the overlay of the ads of the transponder information on flight radar. That's just back in the vehicle, showing the pilots from the pilot seat, the pilot in command, the sensor operator. They'll come in for a landing. This is a very tight landing in quite a hostile environment. They'll do their details complete on the radio.
Tango Oscar Foxtrot, and the Patrick J. Report ready to launch. Tango Oscar Foxtrot.
And essentially that's mission completed. It's just a very brief insight into what happens. One of the issues, and I'll speak very quickly on artificial intelligence, one of the issues that we have is we have a sensor operator that is analyzing a live video feed on a monitor. And one of the challenges that he has is that trying to look for it's like looking for a needle in a haystack. And what we found is that after 60 minutes of time, fatigue sets in, and generally you would miss sightings of poachers and potential issues purely because of the human factor. So we started getting involved in leveraging artificial intelligence to do object detection, and we ended up building an application that we ended up calling SPOT. It was in collaboration with the University of Southern California. It stands for Systematic Poacher Detector Application. And if you look on the left-hand side, first of all, the application, we ended up getting it to run on a gaming-capable laptop that has to have a good GPU and a decent amount of RAM. And the application has turned out to be a really handy transportable application that we can use in the field. And if you look to the left bottom picture, that's an output from, it's a screenshot from SPOT detecting poachers in the field or could be poachers in the field. To the right, the top, we've just got a giraffe that you can see in the raw imagery, and the labeling application and how we handle labeling that particular sighting. And below is the output, which ends up in a highlighted yellow block. So we can start to look for species identification, start looking for poachers, and that's helped us tremendously in terms of making these missions a lot more useful. In closing, and there's a heck of a lot that I've tried to go through very, very quickly. I would need a day to sit down and explain this to you in great detail. But what we've managed to achieve is the ability to fly beyond visual line of sight at night in controlled airspace if required, leveraging AI for object detection. And we've done all of this on a very, very small budget, leveraging off-the-shelf commercially available parts, making these aircraft very easy to service in the field, and giving us longevity and hopefully scalability of this kind of operation to try to combat wildlife crime on the African continent. Thank you very much for your time.